Let's do this problem right here. The question is asking find coordinates of u in the basis b, and the basis and the u are given. So let's see how we can do this. First of all, to do this kind of questions, I have to arrange this in a column space. So if I arrange this in as a column, it's going to be 1 2 1. So I have to multiply xyz or x1 x2 x3, whatever you want, so it doesn't matter. X times 1 to 1, then if I take y, it's y multiplied by minus 2 1 0. The third one is going to be z times 1 1 1, and that's equal to this u. So that's minus 1 1 minus 1. Now I have to multiply, I have to create equations on this. So first equation is going to be x minus 2y plus c is equal to minus 1. The second equation is going to be 2x plus y plus c is equal to 1. The third one is going to be x plus 0y plus z is equal to minus 1. Now I have to take the matrix form. Matrix form is going to be 1 minus 2 1 and 2 1 1. The third one is going to be 1 0 1, and the other side we are going to have minus 1 1 minus 1. Now if I switch this one, this will be much easier because this is the simplest form, so I can switch this one first. So it's going to be 1 0 1 minus 1 2 1 1 1. Then if I swap this one, it's going to be 1 minus 2 1 minus 1 minus 1 in the other side. So let's I have to do the Gauss Jordan. So if I do the Gauss Jordan, to do the Gauss Jordan, I have to eliminate all these values, make this one into 0. So first this one I can eliminate by multiplying the first one by minus 2 and adding to this one. So let's see what happens if I do that. 1 0 1 minus 1, and if I multiply this one by minus 2, it's going to become minus 2 r1 plus r2, which will give us 0 right here. Then if I multiply, this one doesn't change, so it's going to be just 1, and this is going to be minus 2 plus 1 is going to be minus 1, and the other side we are going to have plus 2 plus 2 plus 1 is going to be 3, and in the bottom we are going to have, if I minus this one and add it to this one, so minus r1 plus r3, which will give us 0. Then this is going to be minus 2, and the last one is going to be minus 1 plus 1 is going to be 0. Then we have other side minus 1 is going to be plus 1, plus 1 minus 1 is going to be 0. Now if you see, we have to have 1 0 0 0 1 0 and 0 0 1, right? So if I swap this one, this will be much easier to bring the Gauss Jordan pattern. So I swap this one. Also I can simplify, because if I divide this one by negative 2, it doesn't change other thing because all the others are 0, so we can do that too. So let's do that. 1 0 1, and the other side we have 1 minus 1, and the second one is going to be 0 1 0 and 0, and the third one is going to be 0 1 minus 1 0 1 minus 1 and 3. Now I can eliminate this one by multiplying this one by negative 1 and adding to this one. So let's do that. 1 0 1 minus 1 0 1 0 0, and if I multiply this one by negative and add it to this one, let's see, negative r2 plus r3, so which will give us 0 right here, 0 right here, and this one will be 0 0 plus minus 1 is going to be minus 1, and the last one is going to be negative 0, it doesn't change anything, and the r3 is going to be 3. Now I can add this one with the first one to eliminate the first one. So r3 plus r1 will give us 1 0 0, and if we add this one, this is going to be 2, and the second one we are going to have 0 1 0 and 0, and I can also change the sign right here by multiplying this one by negative 1, so that's going to give us 0 0 1 minus 3. So this is the final answer. Therefore we can write this one as, this is x. Also you can mention x is equal to 2, y is equal to 0, z is equal to minus 3. So you can write this one as 2 0 minus 3, and that's the final answer. So this is first question, and let's do the second question. Second question is asking find the basis and the dimension for the column space, row space, and the null space. So to find the basis, first of all, I have to do the Gauss Jordan for this matrix. So if I do Gauss Jordan, let's see what happens. 1 0 minus 2, 2 1 3, and we have 3 1 1. To eliminate this, so I have to bring everything below the pivot to 0. So to do that, I can first of all I can multiply this first equation by -2 and add to the second equation. That's going to give us -2 r1 plus r2, which will give us 0 right here. Then this is going to be 0, 0 plus 1 is going to be 1. -2 times -2 is going to be plus 4 plus 3 is going to be 7. And the last one is going to be, I can make this one 0 by multiplying first one by -3, r1 plus r3, which will give us 0 right here. And if I multiply this one, that doesn't change anything, so it's going to be just 1. And -3 times -2 is going to be 6. 6 plus 1 is going to be 7. And if you notice that we have second row and the third row with same numbers, so we can eliminate one of them by multiplying one of them by -1 and adding to the other. So let's do that. 1 0 minus 2 and 0 1 7. We can multiply the second row by -1 and add it to the third one. So negative r2 plus r3 will give us 0 0 0. Finally, I have fully solved this one into Gauss Jordan pattern, because all the value below pivot is 0, all the value above and below the pivot is 0. So we have brought this one into Gauss Jordan pattern. Now we can answer these questions. The first question is asking find the basis and dimensions for column space. So column space is basically the numbers. So if you see pivots, we have first column has pivot, second column has pivot. So those are the columns that are going to be in the column space. So we can write, and they are asking for basis. So we can write this one as column space A is equal to basis equal to these two columns 1 2 3 0 1 1. So 1 2 3 0 1 1. So this is the answer for the column space. And then they are asking for the row space. So row space is going to be row A is going to be equal to basis equal, then first and, because if you see first and second row has basis, means second row has pivot, so we have to put that in the basis. So it's going to be first row is 1 0 minus 2, second row is 2 1 3. Those are the two rows that's going to be in the row space. So let's write that 1 0 minus 2, and the second row is 2 1 3, and that's the answer for the second question. And the third question is asking row space and the null space of it. Null space. To find the null space, I had to so null space is basically AX is equal to capital 0, which means if I had to bring this Gauss Jordan pattern 1 0 minus 2 0 1 7 0 0 0 and equalize to 0 and find the answer. So in this case, we know that C is the free variable because X column, these are X, Y, Z columns. So X column has pivot, Y column has pivot, Z column doesn't have pivot. So C is my free variable. Therefore I can solve, I have to give everything in terms of free variables. So let's create the equations. First equation is going to be X minus 2Z is equal to 0. Therefore X is going to be equal to 2Z. The second equation is Y plus 7Z is equal to 0. Therefore Y is going to be equal to minus 7Z. Therefore we can write this answer like XYZ. So it's going to be 2Z comma minus 7Z comma Z. And if I take Z common, that's going to be 2 minus 7 comma 1. And therefore I can write this one as null space the question. So null space is going to be basis for null space is going to be 2 minus 7 and 1. And they are also asking for dimension. For the column space, if you see, we have two vectors, linearly independent vectors. And also you can say we have two pivots in the two linearly independent. It also depends on the pivots. Therefore, if you have two linearly independent vectors, that means that the dimension is also 2. And row space, same thing. If you have two linearly independent vectors, its dimension also 2. And in the null space, it depends on the free variable and the vectors. Like if you have one free variable, the dimension of null space is going to be 1. Also, we can count the vectors. We have only one vector, so null dimension is 1. So we can um, determine by two of these things. So dimension of the null space is 1. So that's the final answer. And that's all about it. I hope you guys like this video. See you next time.